For this video, I really just wanted to do a factorial review. So we know from back in BC that 7 factorial is the product of 7 times 6 times 5 times 4 times 3 times 2 times 1. It's the product of all the integers down to 1 below 7. So 5 factorial would be 5 times 4 times 3 times 2 times 1. Now it's interesting to note for what they do later with variables is that if you look at this part right here of 7 factorial, you can see that 5 factorial is in it. So I could say that 7 factorial is equal to 7 times 6 times 5 factorial. Or if I look at this, 6 times 5 factorial, that is really just 6 factorial. So you can see different ways to break up the factorials into numbers and other factorials. With variables, if we said we wanted n factorial, then I'm going to start with n and I'm going to go all the way down, reducing each product by 1. So the next one will be, it's n times n minus 1. 7 times 1 less than 7, 7 times 6, n times n minus 1. The next one would be n minus 2. Then n minus 3, multiplying all the way down until we get to 1. So if I look at this one and I want to break it apart, this piece right here starts with n minus 1 and it decreases by 1 each time. So that is actually also equal to n times n minus 1 factorial. And you see this both directions. You'll see starting out like this, and you need to actually realize that it's equivalent to n factorial, or you have an n factorial and you need to break it into pieces to actually be able to reduce something. So you can see things, let's say you had an n plus 3 factorial divided by n factorial. Well, if I want to write it out, I'm going to start with the one that is greater. So n plus 3 is greater than n. So I know that I'm going to have n plus 3 times n plus 2, I'm decreasing by 1 each time, times n plus 1 times n, and I'm going to keep going down to 1, but that's n factorial. And the bottom, I also have n factorial. Now I could write more terms out for both here, and then I could write the terms here, but you'll see that I have an n factorial in both, so these would actually cancel out and reduce down to just n plus 3 times n plus 2 times n plus 1. So that's just a basic factorial review. And then they actually use it in one of the problems with an identity leading to the binomial theorem. So I wanted to show you the steps to that and actually see the simplification of the factorial. So it starts with 1 over k plus 1 over n minus k plus 1, and that equals n plus 1 over k n minus k plus 1. So we're starting assuming this is true. And then what they did is they multiplied both sides by the following expression. And it was n factorial over k minus 1 factorial and n minus k factorial. So if you aren't paying a lot of attention, you would just take this expression and multiply it in each one, just putting things willy-nilly. Multiplication is commutative, so it's not that big a deal what order you write this in. They wrote it in a very special order, but I'm going to show you what they did. So I'm just going to take it and I'm going to put these in front of those. So I'm going to write this first, then that. So I'm multiplying by 1 over k, so I'm going to say that this is n factorial over k minus 1 factorial n minus k factorial times a 1 over k. That's multiplying it by this expression. I'm going to multiply it by this expression. I'm just going to keep this one in the front. It really doesn't matter what order you put it in when you multiply. So I'm going to say it's n factorial times 1. Again, it's just n factorial over k minus 1 factorial n minus k factorial, and then I'm going to multiply this term in n minus k plus 1. And that is going to equal, I'm going to take this same expression and multiply it by this one. So I have an n factorial in the numerator, and then I'm going to have the n plus 1. Then in the denominator, I'm going to have all of this, k minus 1 factorial times n minus k factorial, and then I'm also going to have this in my numerator, so times a k times an n minus k plus 1. And then magically they get down to an expression that looks a lot simpler, so I wanted to show you what they were doing. So we're going to look at the order of things that we've written in. So this k is just in the denominator here. So I have a k minus 1 factorial and a k. K is greater than k minus 1. So if you look at this first one, I'm going to put the k in front. So k times k minus 1 factorial is actually equal to k factorial. And you'll see that that's how they've simplified that first expression. For this expression over here, the k minus 1 doesn't really fit these two. These both have an n minus k. This is an n minus k plus 1, and this is an n minus k factorial. So if I write the greater one first, I see that I have n minus k plus 1 times n minus k factorial. This is one more than this, so this is actually equal to n minus k plus 1 factorial. And that simplifies this expression greatly. For this one, we've got more than one thing going on. If you look at the numerator, n plus 1 is one more than n. So if I rewrite the order and look at it this way, n plus 1 times n factorial, that is actually equal to n plus 1 factorial. If I look in the denominator, I have two things going on. I have a k minus 1 factorial and a k. K is one more than k minus 1, so I'm going to rewrite these two and say that I have a k times k minus 1 factorial, and that is actually equal to k factorial. If I look at the last two that are left, I have an n minus k and I have an n minus k plus 1. If I write the one that is greater first, n minus k plus 1 is in fact 1 greater than n minus k factorial. This is actually equal to n minus k plus 1 factorial. And that, once you rewrite it, gives you the expression that they actually gave you in the text.